So you are yesterday signing MOU with several institutions.
IIT Madras also, sir.
Oh, is it? I mean, maybe I don't know who is coming from IIT Madras.
Advait is coming, sir.
Advait. Okay.
Professor Advait is coming from IIT. I think from Kharagpur, Ram Gopal is coming. Professor Ram Gopal is coming from Kharagpur.
Yes.
Okay.
ISC Pramod is coming.
Oh, Pramod is coming from ISC. Okay.
So what is this MOU? Kind of things. What they will try to
Formalizing the association, taking joint consent for taking joint projects,
okay,
and many other capacity building programs.
Oh, okay. Yeah, Professor Mathur, we can start. Many of you have joined now, so maybe we can start, and maybe Lest will go to join in the due course. Are you ready? No?
Yeah.
Okay. Then I'll just share the screen.
Sure.
Yeah, A very good afternoon to all of you, and welcome to Air Quality Management lecture series. This is the 66th month Air Quality Management lecture. I welcome Professor Mathur to this lecture. So just to give you some background about this Air Quality Management lecture series, we started this lecture series in October 2020. It's more than 5 years now. It's first one of its kind in India. Basically, the idea of this lecture series is to provide a forum for young researchers, scientists, and engineers and educators to practitioners to share the latest advancement in theories and applications related to air and indoor air quality. The lecture series includes recent developments, innovations, and use of recent technologies in the area of air quality management. It also provides platform for collaboration with stakeholders and experts from various countries. So these are all our past speakers. Now, just to add a few more, since this is an air quality management lecture series, we also expanded. We have also started Air Quality Management Association in 2022. So the idea of this association is to enhance understanding of the science behind air quality and promoting the knowledge of clean air and understanding best working practices in various communities and provide awareness campaign to the community. So this forum also provides an opportunity to work in the area of air quality management, indoor air quality, health risk, technological interventions, and policy formulations. We also have an Indian International Conference on Air Quality Management. Every year, it's an annual conference. So every year, it held in either in IIT Madras. Alternate year, it's in IIT Madras, and other time it will be in different places. The 11th Indian International Conference will going to happen at IIT Madras in 14 to 18 December, and you can get more details about Air Quality Management Conference in this website. So over to Dr. Lakshmi to introduce the speaker. Today's speaker is Professor Jyotirmay Mathur. So over to you, Lakshmi.
Thank you, sir. Dr. Jyotirmay Mathur is a professor in mechanical engineering at the Center for Energy and Environment, MNIT Jaipur. After completing his undergraduate education in mechanical engineering, he pursued a postgraduate degree in energy studies from IIT Delhi and a doctorate in energy systems from the University of Essen, Germany. Professor Mathur has published more than 180 research papers in referred international journals, presented more than 250 papers or talks at international seminars or conferences, authored and edited 8 books in the field of energy, supervised 27 doctoral students, and holds 2 patents for his HVAC-related innovations. He works in the field of energy, planning, and modeling, building energy simulation, energy conservation in buildings, low energy cooling, and renewable energy system optimization. Besides research, his special interest lies in the field of development and implementation of codes and standards related to building energy efficiency, indoor environment quality, and HVAC equipment. He has also played an important role in various national level committees in India at BEE, BIS, BST, MNRE, and at ISO, IEC, IEA at international level. Currently, he is holding the position of BIS Chair Professor at MNIT Jaipur. Today's talk is titled Indoor Environmental Quality Standard and Human Comfort. Today's talk presents the IEQ standard developed by the Indian Society for Heating, Refrigeration and Air Conditioning Engineers, which was the first of its kind globally, having all the 4 sections of IEQ, namely thermal comfort, air quality, lighting, and acoustics, covered comprehensively. In the talk, the influence of thermal conditions on occupant performance and well-being will also be discussed. We welcome you, sir, for the talk.
Yeah, thank you, Lakshmi. Stop sharing.
So, is my screen visible?
Yes, it's visible.
Okay. So, thank you very much, Professor Srinagar, for giving me this opportunity to talk on this prestigious series. Before I start, a disclaimer, this is not a pure air quality talk. This is a talk in which air quality is a part of it, of course, but I'll present more from the perspective of what makes your indoor environment as such. And as we proceed further in this presentation, I'll emphasize or reveal some of our findings on what happens to occupants' performance when we do provide a good indoor environment or do not provide a good indoor environment. Because finally, what we are working for is why we are providing a good indoor environment is A, we want people to have good health, least possible health hazards or health impacts. B, in offices and other places, or even in academic institutions, we expect indoor environment to be supporting good performance. So that is what was the background of conducting this research, and I'll share some of the findings. So, so coming to the indoor environment as it is seen as of now, there are four major sections of indoor environment. One, of course, is indoor air quality, which most of you are familiar with and you work day in, day out in this space. But the other three are thermal comfort. We all are familiar with it. We'll see in due course how familiar we are. Then we have lighting, also making a very important part of our indoor environment. Acoustic is also making a very important part of it. Why these are important is, and from where the control on these comes is, one is of course the external conditions. External conditions means external temperature affects the thermal part, external air pollution impacts the air quality part, outdoor noise gives the acoustic part, daylight is also impacting by illumination, and green environment nowadays, which is quite becoming popular. People take various initiatives to make a building green. Well, the definition of green is changing from scenario to scenario, but yes, there is some impact of that. Then we have building envelope impacting the indoor environment, which means typically the construction material. Some of them directly impact the air quality, especially when it comes to release of VOCs and other things. You are familiar with that. Construction practices make a very important, play a very important role, because if you have leaky windows or the gap between the sill and the window frame, you have not only hot air coming through that, but also you have pollutants coming through that. You also have facilitation of noise coming in through that, and interiors, of course. We have building services where HVAC system is basically air conditioning system in simple words, which is supposed to cover many things, but unfortunately, in most of the cases, it is covering only temperature and humidity. Ideally speaking, the air conditioning definition itself says that responsibility of air conditioner also is to control the air quality. But in many cases, we have seen that it is not doing so. It is also supposed to control the odor, which is also part of your air quality, but the air conditioning systems and their design do not care for it. So building services typically also have a very major role on your indoor air quality. In many of the cases, especially the central systems, you would have seen there is a lot of background noise, and sometimes so much that people have to shut down their system for talking or listening properly to others. So that is also part of your indoor environment. Last but not the least is people and their activities. Whatever good outdoor conditions are there, whatever good services are there, whatever good envelope is there, you have thermostat adjustments. People can use improper thermostat settings. Windows and doors usage is a very common measure to control indoor environment. But often when we expect the window to be open, people do not open the window, sometimes consciously, sometimes do not unconsciously. So we have actually observed through some of the measurements and some of the observations that a typical mixed mode building by definition is a building which uses air conditioning for some part of the year, but the air conditioner is not working and we allow people to use windows and doors for their comfort and they do not run air conditioner. So mixed use buildings, which typically are designed for not relying on air conditioners and expect windows to be open for controlling indoor environment, do not do so because either the outdoor pollution is very high or the noise is very high, or even we have found in some of the cases when mosquitoes are very high. If you have mosquitoes outside, you would prefer not to open your window. So whatever nice temperature or humidity be there outside, you would not use your window. So that's also controlling your indoor environment, and the building becomes stuffy, and then you have to run your air conditioner. Use of fans and blinds, use of paint, varnish, cleaning, all these things are important for controlling our environment. So there's an organization in India, many of you may not be familiar with it, and hence I'm covering this briefly. Indian Society for Heating, Refrigeration and Air Conditioning Engineers. They realized the importance of this field indoor environment and released a position paper. There was a team of about 10, 12 people working in this field, both from academia and practice. So ISHRE brought out a position paper in 2015, and then all those who were involved, they sat down to develop a standard, which was released in 2016. So this was globally the first standard, as was said in the introductory part also. This was globally the first comprehensive indoor environment quality standard, which addressed all the four sections nicely. After the release of that, there was a research project given by ISHRE. I had the privilege of working closely with Professor Shiv Nagendra. We jointly conducted this project, and our learnings were embedded in the revision of this next version, which was in 2019. And after that, third version, and now we are working on the fourth version of it, in which now we are discussing, can we include more parameters? For example, electromagnetic radiation is there. That is also part of becoming essential part of our indoor environment, and so on and so forth. So the structure of this standard is that there are three levels, A, B, and C. In C, we have kept the minimum acceptable requirements for various parameters, for example, CO2, PM2.5, and all those things, which are either legally necessary or they are the minimum requirements in the different rating systems, such as the green building rating system, and so on and so forth. The B level which is slightly better than the C level, which is acceptable. I would say the building is good if for example, if I take the CO2 level, so ambient plus 700 is the C level, and ambient plus 500 is the B level, if I remember correctly. But A level is the aspirational level. The philosophy was in finding the threshold values for class A under every parameter is that it should be comparable with any standard in the world. People talk about Finland and other countries for good air quality, and they also have standard. So we actually also referred that standard or many other standards like that and matched the thresholds with those things. So the strictness level, the crux is strictness level increases as I move from C level to B level and B level to A level. So the first section, which is thermal comfort, I'll just give a glimpse of what it contains. So most of you would be familiar with an approach that we have thermal comfort. So we control temperature, we control humidity. And when we say temperature, that temperature is air temperature. Typically what we have is in our air conditioners, in our remotes, we have temperature and we increase the thermostat setting, and that actually is sensing air temperature only. But our comfort is not only governed by thermal comfort is not only governed by air temperature. It is governed by ambient temperature, which is the air temperature, definitely, but it also is governed by the mean radiant temperature. What I mean by mean radiant temperature, the term is if we have any extraordinary hot or cold surface in my surrounding, I would have a radiative heat exchange from that. If it is hot, I'll feel cold. If it is cold, if it is hot, I'll feel heat. If it is cold, I'll feel cool. Because radiative heat transfer is one of the most, out of the three modes of heat transfer, most strong heat transfer mode. Because mathematically, if you remember the equation, it is capital T raised to power 4. So Kelvin temperature raised to power 4 and delta T of that is much, much higher as compared to T1 minus T2, which is for conduction and convection. So MRT is to be considered, and air velocity. Air velocity is something which, especially in India, is very important. In Western countries and European countries, people are not happy with if air moves significantly. In India, we are born and brought up in a condition where we love to have a ceiling fan. We love to have an air blast on us for taking away our sweat and all. So, I mean, we are tolerant to more air velocity. And the fact is, through many research papers, including a graph like this, which comes from a ISO standard, but we validated this for India also. And we found that, for example, in this graph, you can see there is a intercept of a velocity of 0.8 meters per second on the y-axis to the x-axis, which is at 3 degrees centigrade, which means if at whatever temperature I am comfortable, let's say 25 degrees temperature I am comfortable with at still air condition. If I increase the air movement in my surrounding and make it to 20.8 meter per second, I will be comfortable at 3 degrees higher temperature than what I was earlier. Means 28 degrees. So the 28 degree ambient temperature would give me the same order of thermal comfort with 0.8 meter per second air velocity as a still air with 25 degrees centigrade would. What it results into is, as a thumb rule, 1 degree rise in my thermostat of air conditioner gives me about 4 to 6% of energy saving. So with this kind of setting only, I'm sitting on a potential of saving about 15% energy, which is tremendous. Okay. And that is why this is not to be neglected definitely when we are talking about Indian context. And that is what is embedded in the H3 IQ standard also. So summarize this slide, we have 3 parameters, and what they come and as a combination make is called operative temperature. Most of the standards world over are talking about this operative temperature, but this operative temperature becomes more or less same as ambient temperature if my air velocity is not there or not significant, and the surroundings are also at the same temperature as my air. But in Indian context, we have, you don't like to sit close to a glass in summer because that is hot and that disturbs my mean radiant temperature. So in Indian context, we definitely need to look into these 3 parameters. So from various researches conducted in India on Indian subjects, this is what is summarized. So the temperature conditions in summer in various offices, conference rooms, etc., should be within plus minus 2.5 up to 24.5, which typically means 27, and on the lower side it's 22. So 22 and 27, it's a wide range. And clothing, because we are adapted people who are there from IIT Madras, who knows better than them that you wear airy clothes which can breathe in summer because of the possibility of venting out the sweat that is that your body is getting. So that is what 0.5 kilo is. 1 kilo means a formal clothing which is not allowing much of airy kind of thing from the clothing. Okay, so the temperature band is specified, a different temperature band for winter and different temperature band for summer. But what we also need to know is my thermal comfort also is governed by many other parameters. For example, the operative temperature I talked about. So the operative temperature has to be seen from that table. Relative humidity, we normally have a notion that relative humidity 50-55% is good, but a wide range of 30 to 70% is actually good. Below 30%, of course, the air quality thing comes into, and many of us would have realized this during the COVID when guidelines were issued, that keep your air humid, because when air is humid, the particulate matter does not travel much deeper into the nasal tract, and therefore the possibility of infection getting inside. Also, it results into dryness and all other things. So humidity lower than 30% is not recommended. At the same time, humidity higher than 70% makes people uh, quite unhappy and quite uncomfortable. And therefore, this is the range. In addition to this, you have limits for warm ceiling, delta T between your room temperature and warm ceiling. You have cool wall, you have cool ceiling and warm ceiling. All these limits are there. Interestingly, there is also a limit on vertical temperature difference. Means at many places, your head is cool, your feet are warm, or the other way around, your feet are cool because air supply is from the beneath, from the floor, and your head stays warm. So the guideline is that it should not be more than 4 degrees so as to minimize the thermal stress induced in the body. Last row is also important, which says occupant satisfaction. In indoor environment, what is seen is sometimes the designers claim that they have a very good environment, but the occupants are not happy with that. So you need to have 80% occupants satisfied. You are supposed to conduct a survey on thermal comfort, and similarly a survey on air quality and acoustic and illumination also. And 80% occupants should be satisfied. Then you are called B class. 90% if they are satisfied, you are called A class. Coming to the next section, which is air quality, and that is of utmost interest for all of you. And as I was saying, CO2 is you can say it's a pollutant, but people also say often that it's a surrogate pollutant. By sensing the amount of CO2, we sense what is the extent of ventilation. You may not be measuring each of the other parameters, but if you are measuring CO2, you at least get a feeling of how good or bad the ventilation is. So ambient is also always taken as a reference of that. And I should mention here, when I'm talking about these values, in the new version of National Building Code 2026, all of these requirements are coming as the basis of design. So the basis of design would include that a building should deliver a CO2 not more than 700 ppm or not more than PM 2.5. Means a designer, whether it is of building architect or HVAC designer or lighting designer, would be obliged or would be really mandated to ensure that these conditions are under control as per these tables I'm showing. So PM 2.5, we have 25 as requirement for C and B class both. So in some of the parameters, we do not have a variation between C and B. Some of the parameters are not there in C. So the philosophy was that because C is the minimum requirement, it should not be very cumbersome. Neither should it be very complicated and costly to monitor all those parameters. But all those essential things should be covered. And that's why PM 2.5, PM10, CO, CO2, and TVOC. These are written. If TVOC is higher than the prescribed limit, then a further elaboration of TVOC is required. And that is what is mentioned in this. Then, because if the requirement is, let's say, if the threshold is 500, I am having 600 or 700, then definitely there is something wrong and I should get into the granularity of it. Each TVOC is not as harmful, and therefore I should really go and check if really the harmful harmful VOC, not TVOC, harmful VOC is there beyond threshold limit or not. And every VOC has a different threshold limit. So in fact, in this, Dr. Shankar Rajshekhar was very instrumental in developing these tables, and we heavily bank in the next version also on him. Well, for visual comfort, again, we have normally a perception that lux level is required. For example, if I have to check illumination on my table is good or bad, I would bring a lux meter, which is lumens per square meter. I measure the lux. If it is between 300 to 500, I'll say it is good. But what the standard says is lux level alone is not important. It brings the concept of quality of light. The 6 boxes that you see on the top left-hand side are same illumination level, means same lux level, but a different color of light. And you would have seen in restaurants, you've seen in hotels and all other places that they like to use a typical shade of light. Why so? Is our body responds to the color of light, different colors of light in a different manner. There is a secretion of different hormones and other things in our body as per the conditions of light. And that is why early in the morning, when the color of light is yellow, we feel very energetic. And as we move towards the night, the color of the preferred color of light changes to pink and so on and so forth. So what this is in very short the concept of EML, which is called equivalent melanopic lux. So lux is not sufficient. It has to be multiplied with a number depending upon the color of light, which is the quality of light. So in LEDs also, if you have bought some LEDs from market, you would have noticed that some of the LEDs are warm white, some of the LEDs are cool white. And if you have the liberty of changing the fixture from warm white to cool white, you would see there is a difference in your perception about the surroundings and all. So therefore, the quality of light concept is very important. Not only the amount of light, whether it is lux or EML, there are other things also related to light, which is uniformity of illumination on your task area. So the standard says that not more than 0.7 disparity should be there. Means if the peak value is 1, the minimum value should not be less than 0.7. And that is what is the uniformity. Not only uniformity on your task area, but uniformity in the surrounding area lighting is also there. At many places, we find that in offices, the aisle areas are very dark. And when a person gets up from his seat, which is quite bright as compared to that, he has some blind spots in front of his eyes for a short moment. And that is where the risk of falling and hitting something is there. So there is a limit on the that uniformity also. Okay. And then we have, of course, the percent of workstation. So in A class building, 100% of the workstation should meet that requirement. And C class and B class, we have 90% requirement. And of course, the occupant satisfaction has to be 80% and 90%. Okay. So the fourth section, which is acoustic, and I'll quickly cover this because I have to cover the finding also. Approach to acoustic comfort section. So in acoustic comfort section, there are three things. One is the noise level limits, because if you have noisy background, typically created by either the air conditioner or other devices, or there is a humming sound from light coming, that should be under limit. Reverberation time, your surroundings have a property of absorbing noise, and that is to be under control. Otherwise, you get an echo and other things. And third is the speech transmission index. Speech transmission index is something which quantifies deterioration in the quality of sound when in the same room I am speaking and you are listening. What quality or what order of sound signals I released are reaching you. That is what is the speech transmission index. And in some cases, we have seen that it's difficult to listen to people very clearly. And that is because the speech transmission index of that surrounding is there. So quickly, there is an elaborate table which specifies different kinds of places, because in each type of place you would have a different threshold limit or different permissible limit for speech distortion or allowable background noise or something like that. For example, if you are in a classroom, you would not like to have a significant speech loss, and therefore a high speech transmission index should be required. The background noise should also be very low, and therefore the noise criteria value would also be low. So that is the fourth pillar of the indoor environment quality. And if you have done really good in all the four pillars, you have a good indoor environment quality. Nowadays, globally, there are efforts, and we are also trying to have the same in the next version of ASHRAE IQ standard is, how can we have a comprehensive indicator merging all the four sections? And there are many schools of thoughts. One is have a weighted average of all the four parameters. And within each section, you have, suppose, 5 parameters. Depending upon the health risk posed by any particular pollutant, you have assign a different weightage to that. But saying is easy, it's very difficult to assign a weightage scientifically to these things. And that is the challenge which is taken up by many research groups world over. And I would be happy if any or many of you present right now take up this as well. So a challenge with us was, in the first version, the project, briefly what I was talking about, are the levels achievable? We developed the standard using literature, but are these achievable? Has anybody tried achieving these in field? So what we did was we conducted a lot of pilot studies in many buildings in Jaipur, and Professor Shivnagendra conducted many buildings and for many buildings in Chennai. And what we found was that this is what was happening in Jaipur. PM 2.5. So the two lines are representing level A, level B, and level C. Above levels B and C line means above the second line is the non-compliance area. So in PM 2.5, you can see in summers, we had more than 50% of the places where PM 2.5 was high. In monsoon, of course, we expect the PM 2.5 in ambient to be low, and therefore the level was low, but not as low. Winters, we had a very high level, and in moderate season also, we had a very high level. PM10 also, you can see that about 50% of the cases only in winters were compliant, and even moderate, you can say slightly higher than 50%. Okay. In summer, we had relatively less, means more points were compliant. What we found in the occupant satisfaction survey was 80% of the occupants had expressed that they have no problem with the air quality. And that is where my duty is to caution anybody who gets into the occupant satisfaction survey, whether it is for air quality or any other thing. The conclusion is we cannot 100% rely on the occupant satisfaction. It has to be substantiated with the measurement. That is what our finding was. Similar was for illumination. You can see these lines, illumination in the left-hand side thing says that 50% of the places were having good illumination. They were in the compliance zone, but 90% occupants said they had no problem. For the simple reason that our eye, God has gifted a very IV flexibility in our eye. We can adapt to the changing illumination situation and challenging illumination situation also. But that is, so if I conduct an occupant satisfaction survey and do not conduct measurements, 90% of the occupants will say that they have no problem, whereas 50% would have problem, and in long exposure to such indoor environment, they would grow medical problems also. So that is precisely what I've already said was the finding of our pilot study. So occupant opinion only is not sufficient, which is the fourth bullet. Comfort and discomfort due to one factor influences opinion on other factor. That is also what we found. So just to elaborate on this point, because that is also concerning the specialization of indoor environment quality, indoor air quality, we found interestingly a good correlation between thermal discomfort and CO2 level. The interiors where CO2 level was high, thermal comfort was also high. And sometimes people complained later on when we went deeper into the investigation and another questionnaire, people realized that yes, because the ventilation was poor, we thought it is also causing some discomfort to us, and they opined that they are not comfortable. So there is a correlation between the temperature and perception about CO2. And that is what is also to be investigated deeper. So we are talking about indoor environment quality, whether we are talking about one pillar of that or all the four pillars of that. Why is it important? The hypothesis is that because of indoor environment quality, our wellness is improved. And when our wellness is improved, our productivity is also improved. Whether we are a student, whether we are a office person, or even any other place I am. So this is what is the hypothesis. So we actually tried to challenge this hypothesis that is it really what is happening? Has somebody tried to cross-check, or it is just a hypothesis and we accept that hypothesis? Well, interestingly, one paper from Harvard Business Review I came across, and that has become my motivation for taking this further, which says that there are many anti-productivity factors in a building. And those which I have highlighted with the circle, these are related to indoor environment quality. It is temperature, air quality, amount of light, visual comfort, noise level, sound privacy. Other parameters are organizational or psychological or other things. But yes, at least these 6 become our responsibility, people who are working on indoor environment quality. Sound privacy is, of course, the highest. Temperature and air noise, temperature, air, and noise there. And light, productivity is least affected by light because of the adaptiveness of eye, as I said. But in long run, that is also not a good thing. So getting motivated by this, we really went deeper into this. So productivity of a person, first of all, what we found was, is a function of organizational culture, is a functional of social environment from where a person is, personal characteristics. Somebody is very productive, somebody may not be that productive. And of course, indoor environment. So that is what was coming out from literature. I'll move further on that. So we specifically analyzed the impact of thermal environment on cognitive function and the productivity of people, occupant performance. I expect some of you to take up this challenge and investigate what happens to the occupant performance with respect to indoor air quality, especially CO2. In fact, one of the students with me is working on the impact of CO2 because ventilation is also a challenge. And we spend significant amount of energy for having high ventilation. If you have higher ventilation rate, the heat ingress in your building is also high and there is an energy penalty. So what is the correlation? What is the optimal? That is what is to be seen. So we have air temperature, relative humidity, airspeed, radiative temperature, controlling my thermal environment. As I said, clothing, insulation, and metabolic activity is your personal attribute. So that is personal choice. But there are 4 basic things which are to be looked into. One is the attention, the span of attention, how deep is the attention, and so on and so forth. Memory is also a cognitive function which affects my performance. So short-term memory, long-term memory, free recall, verbal memory, all those things are there. Perception, how is my perception? There are 4 kinds of perceptions. And then we have high order skills. So some reasoning functions, some planning functions, some problem solving, and all these things. And there are certain tests. So there are international protocols for conducting these analysis. and there are questionnaires. So what we did was we had in different settings, this is just one example. We conducted these in classrooms also, we conducted these in office settings also, research labs also, and we found that, so this is the glimpse of the variety of conditions that we had during this analysis. So all those tests, a series of tests actually, I'll come to that slide, was conducted. So there were subjects in winter, we had 96 subjects. Summer, we had 48 subjects. You can say that this number of subjects is less, but I'll tell you later why it is so difficult. Even this number is, as I'm saying, till this research was conducted, this number was world's highest. Most of the papers that we were finding had 20, 25, 30, at max 40 subjects. Okay, so we had air temperature ranging from 15 to 24 in winter, 24 to 33 in summer. In winters, definitely air velocity doesn't make sense, but in summers, we varied the air velocity from 0.2 to 1.2 meters per second, which is the agreeable limit normally. After that, the draft makes you uncomfortable. So the total number of samples we collected was 384 and 576. And we conducted tests on thermal sensation, thermal comfort, mood disturbance, willingness, well-being, and all that. So there is a series of neurobehavioral tests which are accepted internationally. And some of these tests are also conducted for astronauts who are sent by NASA and other similar organizations. So we actually found those protocols and conducted those tests. This is how the test is conducted. So first of all, the thermal adaptation, or maybe you can say environmental adaptation. A person comes in the room, so immediately he is not ready to give the test. So we allow about 30 minutes settling time. So settling time means when he comes out, maybe he's tired, maybe he's climbed stairs or whatever. So he settles down, his metabolism settles in. And after that, we take some physiological measurements. And that is where the problem comes, because unless you have ethical approval, there is an ethics approval committee in every institute. So you need to have ethical approval for that, because you are measuring personal attributes, for example, SpO2 and heart rate also. So we measure that. If that is within the acceptable limit, then only the subject goes to further stages. Otherwise, he's not allowed to take the test. Then we have subjective measurement. So there is a thermal comfort assessment. There is a mental state, willingness assessment. There are some tests and survey questions which are observed. And then we have objective measurements, neurobehavioral tests. There is a series of tests. For example, a very simple thing, you add digits, 2-digit numbers, you add 3-digit number, you add memorize a 5-digit number which is given to you, and so forth. There is a series. Color recognition, or maybe some of the tests that few of you must have done during color blindness test. So those kind of tests are also there. Shape recognition tests are also there. So there is a series of tests which is conducted, which takes 30 minutes. And then after those tests are conducted, again, some subjective assessments related to mental workload assessment, means how tired you are you willing to take up some more tasks, and so on and so forth. So all in all, if you see, this is more than 1 hour affair, 1 hour, 20 minutes typically for one cycle. And this time you have to spend on one person in one go. It's possible that you get 100 students, you get 200 students, 500 students in an institute like ours or IIT Madras or any other. But once you go to these students or office officials every 15th day or every 20th day, because the settings have changed, after once or twice cooperating, they would start rejecting you. They would say, no, I don't have time. It disturbs my work, and so on and so forth. And that is what makes it complicated. And that is why I come back to the fact that in most of the publications, you would find that such tests are conducted on 15, 20, 30, 40 at max subjects, because even we needed to spend a lot of money for keeping them motivated. And we needed to ensure that they don't memorize the test, and so on and so forth. So this is about thermal sensation. Thermal sensation, obviously, in winters, we had relatively lower temperature at which they were comfortable, summers a little higher temperature at which they were comfortable. But interesting is that so in thermal comfort, winters, we also expect that they would be really fine at a slightly cool environment, but it was not so. You can see the graph at the bottom and the curve which is there. It is peaking at a higher temperature as compared to the peaking time of summer temperature. Means people like to be in a slightly chilly environment in summer and slightly warm environment in winters, against the normal notion that we will be okay at a lower temperature. This is what we found. More interestingly, this is also what was our finding, that the mood state is also a function of temperature. So in the mood state, what we found was that in summer, the mood disturbance was minimum when the setting was slightly cool or neutral. When they were feeling slightly warm, the mood disturbance started increasing. When they were feeling slightly cold or cool, the mood disturbance also started increasing. Reverse was the situation in winters. When they were feeling slightly warm or neutral, the mood disturbance was decreasing. In fact, with slightly warm condition, the mood disturbance was minimal. What does it indicate is unlike the hypothesis of thermal comfort, they always tend to recommend that when people are neutral, keep that temperature setting. But what our mood disturbance study says that when they are feeling slightly warm in winter, keep that temperature setting. When they are feeling slightly cold in summer, keep that temperature setting. And that is what was against the prevailing hypothesis. We also conducted some willingness assessment test, and willingness assessment tests also interestingly revealed the similar things. You can see the two graphs. For the black one is for summer and the red one is for the winter. You can see winters, basically willingness to work more was higher when the environment was slightly cool. And in summers, the willingness to work more was higher when the environment was slightly warm. Well-being, there are a lot of checks for well-being, for example, dryness, giddiness, eyes burning, and all those things. And again, the well-being assessment was also revealing the similar situations in summer and in winter. In summer, you can see that again, the same thing, the well-being was better if the person was slightly cool or neutral. In winters, the wellness was better if the person was neutral or slightly warm. So we also had, out of the quantitative assessment, the assessment of overall performance of persons. And that is what is important. We expect our students to perform good. We expect our researchers to perform good. So what kind of temperature settings would make them work best? Because if you remember in JEE, one question right or wrong makes it or breaks it. Okay, so therefore there is a lot of impact as far as even your grades change. If those who are students, your grades change by increase in 3 marks or 5 marks, whatever be the scene. And therefore, what we found again was that the performance of all these students and officials was also high when the environment was neutral to slightly cold in summer and neutral to slightly warm in winter. Then the order of reduction in performance, you can see on the larger graph that the order of reduction was as high as 10%. Of course, the bandwidth was high, but on an average, over a temperature difference of 3 degrees from a very preferred temperature to towards the non-acceptable limits, the performance decreased by 10%. And that is only because of temperature conditions minded. We have other parameters also that would affect your productivity, typically the lighting, typically the air quality, sound, and all. So we just cross-checked how our findings were with international studies, and we found that the trends are pretty much similar in other studies. But more importantly, what I want you to sensitize about, and maybe towards the end of my talk today, 10% is the productivity loss that we have seen in the graph, and that is only because of temperature and humidity, of course. If I combine the lighting, the productivity loss due to lighting, the productivity loss due to bad air, improper ventilation also, and acoustic disturbance, background noise, and illumination, this will be much higher than 10%. I am taking a very conservative 5% productivity loss, and let us evaluate how much is it. Suppose I take a building of air-conditioned building of 10,000 square meter, which typically 1 lakh square feet. The construction cost of 3,000 per square feet gives me a cost of 30 crores of this building. EPI is the energy performance index. Energy performance index is the electricity units you consume per square meter per year in any building. And 100 is let me tell you, from the Bureau of Energy Efficiency benchmarks, is an efficient building. So this is an efficient building. The cost of energy, if I take 10 rupees per unit, the electricity bill it pays is 1 crore per year. This is about the energy. The cost of electricity over the lifetime of a building, 40 years life, or 40 crores. If I take about 10 square meter per person, which typically is there in many IT offices, maybe even lesser area, I would house about 1,000 persons in this building. Every person on an average getting 10 lakh rupees per year as a salary, my salary bill is 100 crores in a year. So the salary bill is nothing as compared to the cost of energy. And it is even nothing as, even the salary bill is much higher as compared to the cost of energy. And the building cost also is much lower as compared to my annual salary. We have, suppose 5% productivity loss. So my cost of poor IEQ is 5 crores. 5% productivity loss, 100 crores is worth of their productivity, which is their salary. So 5 crore per year is the cost of poor IEQ, whether it is coming, as I said, because of temperature, because of air quality, because of anything. Why this is important is why we should sensitize building operators for this is many times we have seen that they have removed filter from the air handling unit. Sir, this is increasing the pressure drop and this is disturbing the energy bill. Okay, they remove it. Many times they close the fresh air vent. Sir, outdoor air is very hot. It is increasing the heat load and therefore energy consumption is increasing. What we can see here is the energy cost is 1 crore only, the total. Even if I save 10% of that, that is 10 lakhs only as compared to the loss I have with a very conservative estimate is 5 crores. It is nothing. And therefore, we should definitely force them literally to ensure that there is a good air quality and there is no compromise on the air quality. Because of the time limits, I'll stop here. This is some of the work that we have produced in this. The last part of it means the productivity analysis and all. So this is one journal, Building Environment from ASHRAE. Then we have Energy and Buildings. This is a paper, and there is another paper in Energy and Building revealing some of this. So with this, I would conclude, and I'm told that there are some questions in the chat box.
Yes, yes. Sir Mathur, there are some questions. Maybe there's some question. Okay, what other factor influences EML apart from luminescence?
So color of light is the most important parameter. So color of light. So if you have the same lux level, but a blue light or a yellow light or a pink light, the EML would be different. So what you have to find out is what is the color of light. CCT, it is represented by CCT, correlated color temperature. So on any lamp, you read the value CCT. What is the CCT value? And that CCT value through a conversion table will give you the lux level multiplied by a factor. And that is what your EML level is. So this is what is the interpretation of that.
Okay, so before others also use chat box to type their questions, maybe I'll request everybody to start their camera. We'll have one online photo, and then we'll continue the discussion. Yeah, Professor. Then it will also give some time for Professor Mathur also to get some break.
No, it's okay, fine. 1 hour is typical class time, so it's no problem.
Yeah. Yeah, could you please, all of you, start your camera? Lakshmi, have you taken? Okay. Yeah, Professor Mathur, I just would like to know, indoor air quality standards not, implemented in many places. That's a major challenge. So I don't know. It needs more an acceptability from the architecture point of view also, because in fact we design something, but finally the architecture was the one who is influencing in implementation. So how do you? It's a great challenge. So how do we address this?
Yeah, so we tried sensitizing them. You know that this standard was launched in 2016, and over past a decade we've been trying. So one good thing is that Indian Green Building Council has a wellness rating for buildings. So compliance of the standard, including the air quality thresholds, is a mandatory part of that wellness. So any building which is taking a wellness certification has to comply with the requirements, the C-level requirements at least. Okay, and they score higher points as they improve the quality. That is one. But as I was mentioning, we have this time inserted these requirements in the National Building Code. There is a section, Part 8, Section 3 for HVAC design, air conditioning design. And so in the basis of design, people were only doing it for temperature and humidity, as I said. Okay, but now this time we have given all these tables in a very elaborate manner,
Yes.
with explanation also in the National Building Code. So many architects actually follow National Building Code. In some of the districts and ULBs, compliance of NBC is mandatory. So we hope that through NBC we would find a inroad. Another development in the meantime is Bureau of Energy Efficiency had a code which is called National Building Code, Energy Conservation Building Code, ECBC, which now is enhanced to become ECSBC, Energy Conservation and Sustainability Building Code. So there is a chapter on indoor environment quality in that also, which we've inserted, again, having the same threshold requirements. So any building which now would be energy efficiency compliant would be mandated to ensure the air quality and other illumination and acoustic quality compliance also. Primarily, the message is that don't be myopic towards energy. You should save energy, but without a compromise on other parameters, including air quality, lighting, and acoustics. That is where we are as of now. But yes, it's a challenge. People would need, but there are many. I've seen few hotel chains adapting this and showing the compliance of this standard as their marketing strategy.
Yes.
Typically, the Oberoi group of hotels, I have seen a big display in the reception of Oberoi Hotel Delhi about the air quality, and they're displaying that these are as per the threshold values specified in the standard. So there are many people who have, I mean, there is an inertia, you know better than me, for adopting these things. But yes, things are improving, but yes, we'll also do capacity building and all of that.
Yeah, I think the other aspect also, as you rightly said, now there are all the shopping malls. They are also started incorporating this sensor-based air quality and human comfort information. So I hope this will drive the the initiatives.
Yeah. And one of the things that I have personally started doing is confronting designers directly from forum. Although it feels bad, but especially these split air conditioners that we use is a big menace. People use split air conditioners and meeting seminars rooms, and I have personally recorded 7,000 ppm CO2 in some meeting rooms, which were heavily crowded for more than an hour. And then at the end of 1 hour, the CO2 ppm was 7,000, which is criminal. Okay, but people are not opposing. People using split air conditioners in hospitals, which is again bad. So at different forum, wherever I get opportunity, I've started confronting them and advising them for not doing this, sensitizing them what wrong they're doing. That's it.
I agree. So the other question, since there are many researchers attending this talk, so from your point of view, since there is a lot of interdisciplinary things are happening, and in fact, we, Professor Maya, and we all going to work, in various aspects. So what could be the kind of the near future research question? One, because the energy is also another aspect we always key in looking into that. So, and comfortness is another aspect. So what kind of research question will be useful to the researcher? Do you have some thought on that in that direction?
So one important that everybody is struggling with is, and even ASHRAE has released a position paper about the CO2 thing. CO2, we know that there are negative impacts of CO2 on metabolism and all other things, but the threshold values of indoor CO2 are still questionable in different settings. So those, and what order of, as I said, in thermal, it was easier to control the conditions and see what order of productivity loss is there. Similar studies are to be conducted for CO2. Productivity loss would still be easy to determine, but the health impacts, quantification of that, and then setting thresholds for, because there are, on many forums, there are debates on what is the right level of CO2 indoor, what is the maximum permissible, what is the order of impact on health, and so on and so forth. And therefore, the ventilation norms, ventilation standards, typically ASHRAE 62.1 and other standards, they keep revising the recommended ventilation rates. Earlier, it used to be 15 CFM plus 0.06 multiplied by the area. Then it came down to 10 CFM per person plus 0.06 times the square feet area. Now people are saying it should be 6 times CFM per person, and so on and so forth. So people still are not very confident what formula should be given for the ventilation rate. And the ventilation rate is also, as I said, quite a deciding factor for energy efficiency of a building. If I have high outdoor air, I would have higher energy consumption. So therefore, there is a good amount of research required for CO2 itself. Same, I'm sure, would be there for other parameters. VOC is typically there, which is very sensitive, very impactful, and so on and so forth. My concern is we see all of these in isolation, depending upon our area of expertise. Indoor environment is not to be seen as an isolation, and that is what DTU is doing. We are working with DTU on that, how these interrelate, how these parameters interrelate. So that interrelation also needs to be investigated.
Yeah,
I hope I answered your question.
Yes. The other things which I'm trying to look at. So there are these days the personalized ventilation is also gaining interest.
Yes.
So now when you try to look at it from the centralized air conditioning to personalized air conditioning. So how do you look at it? What way it will go? Maybe do you feel that centralized will be replaced with ventilation, personalized ventilation in the future?
It's good. Technologically, it's good. It sounds promising, but when it comes to offering and designing a personalized ventilation system in buildings, there is a challenge. In fact, in some of the buildings, typically Wipro tried to have that in their building, and many other research labs also. There comes a limitation in the layout, and there comes a complication in designing the system, in providing the vents right to the desk of every person, and so on and so forth. So it increases the first cost also. But yes, once it is provided, it's a tremendous thing to happen. So right now, architects don't like it because it limits their flexibility. And that is why, to my understanding, that is not coming. So there is a question in the chat box. You said about the use of AC in the room, especially in commercial buildings. But irrespective of season, why do we feel somewhat relaxed when we enter AC room when it has high amount of CO? Is it something modern ACs with presence of negative? Okay. So, both yes and no. Earlier, when I grew up, that was an era of window air conditioners, which used to have a small vent of outdoor air. Okay. So there was still some fresh air coming. But later on, as split air conditioners started coming, that practice went away. We feel nice because of thermal comfort. And as I said, there is a correlation between the two. Sometimes because we are thermally comfortable, we don't realize the severity of a indoor air pollutant, and vice versa also. So this phenomena is, I feel, because of that correlation, which still needs to be investigated. But given the situation, we are really having a very bad practice of using split air conditioners. And some people who know about this, they keep the window slightly open to let the fresh air come. If you compare, okay, fine, I put your question in some other way. You do this exercise twice. Keep two rooms, one room catered by split air conditioner, keep the window slightly open. The other room, keep it fully closed. You go outside, be equally uncomfortable in both the events. Go in one room, come out, go in a room. I'm quite hopeful that you would find a perceptible difference in both the situations, and that is what proves the importance of outdoor air.
Yeah, that's true. Yeah. So, any other questions from audience attending this lecture?
May I ask a question, a small question, sir?
Please.
Go ahead, Guptaji.
I listened to your lecture and I was disturbed by one observation of yours that occupant satisfaction is not very important from your point of view. You rely more on measurements. Whereas I feel that occupant's satisfaction is the most primary thing. If there is a nuisance, occupant will say, yes, there is a nuisance. And if there is no nuisance, he will say everything is fine. Then why do we need a measurement?
So first of all, I correct the interpretation. That my conclusion was occupant satisfaction alone is not sufficient. Because
but that is the
occupant
primary
satisfaction.
consideration. But that should be the
No,
primary
no. So
consideration.
that's what I'm saying. Sometimes occupants are not sensitive enough to realize variation in a parameter or something.
Why do you
Because
say that, sir?
elimination, you
Why?
yourself can check. You measure the lux level at 10 different desks. I'm pretty sure at 5 desks you will find it below the acceptable level. But people are not complaining because of adaptiveness of our body. The adaptiveness of our body is high, and that is why we should correlate the two always. Always do not, I agree that occupant satisfaction is important. So therefore, always conduct it. I'm not saying don't conduct it, but supplement it with measurement also.
But sir,
Okay.
this adaptability is different, varies from person to person. Some person may be
Agreed.
So it cannot be a one uniform value that this will be
Yes.
acceptable or this will not be acceptable.
Precisely. And that is why the era of personalized environment control is coming. What Professor Srinagan raised. Because it is adaptation is a personal phenomenon, you very rightly said. Okay, I may be more adaptive, other person may be less adaptive. So therefore, a personalized environmental control where I have control on my temperature, my humidity, but I may not have a same order of control on the fresh air, same order of control on filtration. So some of these parameters are easy to provide as personal environment control. Some of these are not so easy to provide as personal environment control. And therefore, measurement, importance of measurement cannot be denied.
No,
Best is blend with
I
it.
agree.
And that's why, if you remember, or maybe I can bring up that slide, in each of these tables, we have the measurements, and in the last, we have minimum 80% occupant satisfaction has to be there. So even if all of your measurements are under control, and if less than 80% occupants are satisfied, we still do not accept it. That is what is the interpretation. And that is what probably answers your question, that it is not to be overlooked, but it is not solely to be looked. That is how it is.
I think just to Guptaji, to what Professor Mathur said is occupants, acceptability is important. At least minimum 80% they all feel what measurement shows, and occupants also feel comfort. Then we are right with that.
Agreed, sir. But my point of saying was that the measurement alone should not define whether it is satisfactory or not satisfactory.
No. It's only indicating. So it's based on the thermal graph indicating that this is the kind of a comfort.
Right. But, second question, second observation, not a question, that like we have an AQI now, why not we have a comfort quality index for indoor environments now?
Yeah, so that is what we are trying to have.
So we should have CQI, which comprises of VOC, PM 2.5.
Badly needed.
Yes. If we have that, then people will be less confused, and they will say that, yes, this environment is comfortable or not comfortable to me, or healthy or not healthy. Maybe I will say healthy or not healthy. Can you see my screen? Can you see my screen? Yes, I can. So bullet number 5 is occupant opinion only is not sufficient. That is what is the conclusion. I'm not saying occupant opinion is not good. Okay, I missed that word only. I missed that word only. Sorry. Fine. Okay. Thank you. That's all. Thank you. It was a excellent lecture. We learned a number of things out of this. Thank you very much.
Thank you.
Yeah, Professor Mathur, thank you very much for agreeing to give a talk in air quality management lecture series. It was a great talk, and we learned a lot actually with your great experience working with industries and also the various agencies. So that experience was reflecting in your talk, and so nice of you. And thank you very much. And we look forward to see you sometime in IIT Madras.
Sure. Thank you very much. I thoroughly enjoyed it. Thank you. Good day.
Thank you all for joining the air quality management lecture series, and keep attending every month. It will happens maybe third Friday. Thank you.
Thank you, sir. Thank you.